We're looking at the price of gasoline example, and we have our variable of interest, geographic region, that is the treatments. So we have 5 treatments: Vancouver, Toronto, Calgary, Saskatoon, and Montreal. And we have 6 different brands, which are blocks, A, B, C, D, E, F, but they could represent Esso, Petro-Canada, Costco, and so forth. So they could influence the response because the price of gasoline do vary from brand to brand, and they do vary from city to city. So we can conduct a test to see if there is a statistically significant difference between them. So if we're setting up the null hypothesis for the treatments, so this would be for the treatments, that's the cities, there's 5 cities, we would have the true average. So this 1 would be Toronto or Vancouver, 2 would be Toronto, 3 would be Calgary, 4 Saskatoon, and 5 Montreal. And then that would be against at least 1 of the treatment means. Treatment, I meant to say treatment and put means. So treatment means is different from the others. And if we did the blocks, so that would be, the null hypothesis would be mu1, so that would be brand A. Brand B would be 2, 3 would be C, 4 would be D, 5 E, and then F would be 6. So 6 different brands for the blocks. And the same thing here against the alternative hypothesis, at least 1. So at least 1 means 1 or more of the block means is different from the others, is different. All right, so that's how we set up the test. We will check out for both. And if you go to page 458 in the course textbook, you will see the derivations for the sum of the squares. Okay, so I have put those sums of squares into the table here with the corresponding degrees of freedom and also the mean squares. There's one value missing right here because we're going to check out the blocks too. If you take the mean square for the blocks divided by the mean square error, you will get 0.63, or you should. Right, so we can look at the observed F we get for the treatments, I'll put a T there, is 18.96. And let's compare that to the table F. So the critical value F on alpha, 0.01, that's going to have 4 degrees of freedom and 20 degrees of freedom, because to get 18.96, we took the mean square for the treatments and divided it by the mean square of the air. So that corresponds to 4 degrees of freedom and 20. So we'll find that one. And then for B, I'll put here blocks. That's 0.63, very small number. The table value or the critical value, 4.01. This time that will correspond to 5 degrees of freedom and 20 degrees of freedom. So we need to go to the F distribution table, find those values. So here is alpha, 0.01. And for the first one, we had 4 degrees of freedom corresponding to 20 in the denominator. That gives us a 4.43. So let's go back. That's 4.43. 4.43. So you can see that F is greater than the table F. So the observed F from the data is greater than the critical value from the table. So then we reject the null hypothesis. So the null hypothesis was that the 5 treatment means, the true means, were equal, and we're going to reject that. All right, so that means the test is statistically significant. Let's check out the brands as well. So we want to go back to the F distribution table. This time we want to look at column 5 degrees of freedom with 20, 4.10. In this case, the brands, so that was going to equal 4.10. F is not greater, so the observed value is only 0.63, is not greater than the observed table value. So we do not reject. And we would conclude then that the averages between the brands are equal. We would accept that because we cannot reject it. So we would conclude that that holds, but we would reject the null hypothesis for the treatments that the 5 cities are statistically significantly different from each other. The means are different. So that is how you do the price of gasoline example.